Hello, and welcome back to the Product Academy. My name is Javier Roldán. I am experimentation lead at Adevinta Spain, and also I'm the content owner of the experimentation module in the Product Academy. As an experimentation lead, my goal is to help teams do good experiments in order to develop our products in the best possible way. We have seen in lesson 8 with Anastasia how to define a good metrics when running an A/B test. In this lesson, we are going to learn about sample. What is and how important is the size and representativeness when defining your sample. Before starting with the lesson about sample, let's do a little summary of what we have seen so far. As a team, we are working on an opportunity. We have defined an hypothesis. We know where we are going to test. We know also which metrics we need to monitor. And now we need to decide whom to test with. So we need to define our sample. Let's look at all the concepts related to the sample definition in our A/B test canvas. We are in block 5, experiment configuration. And we see that in order to determine our sample, we will need to describe the following concepts: power, significance, MDA, and direction. Again, power, significance, MDA, and duration. Okay, let's go for it. What is a sample? As we have seen, A/B testing is a type of experiment that allows us to learn what works and what does not work in our product, impacting only a small part of our audience. In this way, we minimize the risk of showing a version of our site or app that occurs. Again, in this way, we minimize the risk of showing a version of our site or app that our users dislike and give us the possibility to be more daring. This small part of our audience is known in experimentation as sample. But not any portion of our audience is an adequate sample to obtain valid insights for the entire population. Our sample must allow us to apply the learnings we obtain from it to the entire audience. A good sample needs to have the right size and have to represent our audience. Let's see why sample is so important when working with samples through an example. Let's imagine that we have a normal coin, heads and tails. We all know that when tossing a coin, we have 30% probability that it will come up heads and 30% that it will come up tails. Let's also imagine that we do a little experiment to verify that this is true, that our coin meets that proportion. And we decided that our sample will be the result of flipping the coin 5 times. We do it, and we get 4 heads and a tail. Okay, if we stop the experiment here and try to draw conclusions, we will say that our coin have 80% probabilities of come up heads. We will falling into error. What's going on? We are in error because we are considering valid a result that is not statistically significant. Let's go through this concept.